Hello and welcome to this tutorial on basic colour theory. There have been some great improvements over recent years to the way SignLab handles colour management, and our latest release of this award-winning software is no exception. To help you understand these new features fully, we have created this introduction tutorial which will explain the basics of colour theory. Some years back, when the only printing sign makers had to worry about was that of their visuals to a desktop device, I would often be asked why the colours they had chosen on screen were different from those that had actually printed out. The answer then remains the same now, and that is simply that monitors display in RGB colour space and most inkjet printers print using CMYK colour space. The difference now, of course, is with the development of colour management software and hardware, it's easier to define a good match between what we see on screen and what is produced in print. With an ever-increasing number of people within the sign and display industry running some form of large format digital printer, achieving the right colours in print has never been so important. The addition of digital printers in our sign shops has happened at such a fast rate, I'm sure many of you using them may never have had the opportunity to fully understand colour and how it affects the way we view and print our images. In this next step of the tutorial I will explain the basics of colour theory, so if you have some understanding of this subject already, or if you're a complete novice, watch to learn more or just brush up on the facts. Okay, so let's start with your desktop monitor. Regardless of whether you're using an older style CRT monitor or one of the newer LCD models, the colours used to display the images you see in front of you right now are red, green and blue. This will usually be referred to as RGB colour space. RGB is actually the closest representation of the way humans see colour. It's also the system used with your television. Digital cameras and scanners also capture using RGB colour space. Different numerical values of these colours are mixed together to create the colours displayed on screen. These values are set on a scale from 0 to 255. Watch this simple demonstration to see how the colours are altered as I adjust these three sliders. White here is achieved by selecting 255, 255, 255 and black by selecting 000. The range of colours that can be achieved on a specific device, in this example a monitor, is often referred to as the colour gamut. This illustration displays the colour gamut of my monitor, represented here by the enclosed black line. The larger this area is, the more colours can be achieved. Okay, so we know the basics of monitor colour, but what about when we print an image? Well, the majority of large format digital printers apply colour to substrate using cyan, magenta, yellow and black inks. This will often be referred to as CMYK. So like the RGB monitor, my CMYK printer also has a range of colours that are achievable by mixing different quantities of the four inks, and this makes up my colour gamut for this device. Let's take another look back at the illustration. We can still see the gamut achievable by our monitor, represented by the black line, and I have now added this yellow line which represents the colour gamut of my chosen printer. Straight away you will notice the huge number of colours that are outside the range of my printer gamut but achievable within my monitor gamut. In short, not every colour we can see on screen is achievable in print, and in most cases RGB gamuts are much larger than those defined in CMYK. In addition to the major differences between the gamut of a monitor and a printer, you will also find variations between similar devices that operate with the same colour space. One example of this is two different manufacturers of monitor. This animation will explain more. Let's keep it simple and say the design house has created this square using the RGB value 51, 102, 204. And this is how they would see the chosen colour on their screen. Now take a look at the same square displayed on the monitor of the sign shop. Although it is being represented by exactly the same quantities of RGB, the visual perception of this colour has changed. This is because the various RGB colour spaces used with monitors are what we call device dependent. Differences in manufacturing or styles of monitor will all have an effect on the colours they can display. This theory also applies to output devices. We could run the same print on identical machines, but if they both use different brands of inks, the results may differ. Again, this is because the CMYK colour space of these printers and the inks used are device dependent. In order to manage our colour better and overcome some of these differences between devices, we need a colour space that is device independent. We call this LAB colour space. We can use LAB to build comparisons of the colour characteristics of different devices, and this is the basic building blocks for colour management. To ensure we know the range of colours achievable on a given printer, it's necessary to create an ICC profile. To do this, we basically print a series of charts with different combinations of colour value and then read them in LAB colour space using a spectrophotometer. The tutorials on using our calibration wizard will explain more. The resulting ICC or output profiles are used when an image is printed to achieve accurate colour representation. So when we look at an image on screen in SignLab, we can choose to do this using the output profile of the printer we intend to use. Managing colour in this way will ensure that we can only see on screen what we can realistically achieve in print. The other side of colour management is having a correctly profiled monitor. All we have just spoken of will count for nothing if we do not have a display that is also calibrated to a known standard. When I spoke of creating ICC profiles for specific printers, I mentioned spectrophotometers. These are not the cheapest pieces of equipment to buy, and this is one reason why wherever possible CADlink will try and provide you with profiles to suit the printer, inks and media you use. When it comes to buying equipment for profiling monitors, there are a range of devices available at affordable prices. These will undoubtedly help you calibrate your visual display unit correctly. Most monitors will be supplied with a profile from the manufacturer, and in many cases this will do a reasonable job. But to complete your colour management system, we recommend checking out one of these devices. You would not want to measure up for your next sign with a tape measure that was 2 inches out, so why put up with a monitor that is not displaying your achievable colour range correctly? For more information on calibrating your monitor with an external device, why not have a look to one of these sites: www.i1color.com, www.monocosys.com, or www.colorvision.com. These three companies all manufacture devices for calibrating monitors. So to summarise, all colour imaging devices have different properties. Ensuring you have the right settings in place will enable you to manage these differences and get the results you need from your equipment. The changes in the latest version of SignLab have made colour management easier than ever before. Simplified steps together with informative online tutorials make an otherwise complex subject easy to understand. So with your new knowledge of colour and a basic understanding of how it works, have a look at the tutorial we have created on these latest changes and how they will improve your workflow.